Hello, good people. Welcome to my platform. All right, we are given this question uh, on this topic, um, partial fractions. On this topic, we are given a certain question. Then we are asked to express x plus 24 over x minus 4 plus x minus 3 in partial fractions. All right, so whenever you are given a question based on partial fractions, first of all, we have to check, well, if the given question you are going to express in partial fractions, which way or form you are going to apply. Is it linear fraction? Is it linear fraction? Is it quadratic fraction? Is it linear repeated? Or is it improper? Are you going to express it using improper way of expressing these fractions in partial fractions? So first of all, you have to think about four ways of expressing these partial fractions. First of all, you can use linear, you can use quadratic, you can use linear repeated, you can just use way of improper. All right. If you checked well, on this one, the highest power of x is 1. If the highest power of x on the denominator is more than 1, meaning to say you are going to apply quadratic. If the highest power of x on the denominator is greater than the highest power of x on the if the highest power of x on the numerator is greater than the highest power of x on the denominator, meaning to say that's improper. You are going to use long division by application of improper way of expressing in partial fractions. If you are given this and this, then you are given a certain power on the expression, or the one of the expression is doubled, meaning to say you are going to apply linear repeated. But from this condition, just given this singular expression and this singular expression, then you ask it to express in partial fractions. So basically, what you have to do here is we have to apply linear way of expressing in partial fractions, right? Since we are given x plus 24, everything over x minus 4, x plus 3. So for us to come up with a good solution, since you noticed, then you check on and you come up, this is a linear. We have to apply the linear factor. So this becomes a over the first factor, which is x minus 4, plus b over the second factor, which is x plus 3. So we want to find the value of a and the value of b. The value of a and the value of b. Just remember, the one what you call partial fractions is just an advanced way of dealing with algebraic fractions. At ordinary level, you will be given, when there's a number here, then you ask it to express as a single fraction, then you obtain this. Now it's reverse. We are coming from the single fraction to come up with the two expressions which we express in order to come up with this solution. All right. So for us to come up with this solution, you can multiply by the LCM. The LCM for this, and this. And this one, that's the LCM. You multiply here, you multiply here, you multiply here. So let me just apply it. So x plus 24 over x minus 4, x plus 3 is equals to a over x minus 4 plus b over x plus 3. Right, from there, let me just multiply by the LCM. Multiply here by x minus 4 x plus 3. Same applies to here, x minus 4, x plus 3. Same applies to the last one, x minus 4, x minus 3. This, we'll cancel this. Only left with x plus 24 is equal to this thing. We'll cancel this. Left with a is multiplying x plus 3 plus b is multiplying this. This will cancel this. We have x is x plus 3 here. This will cancel this. Left with x minus 4. Right, remember our aim is to find the value of a and the value of b. Then we substitute here. So from there, for us to come to find the value of a and the value of b, you can just use this way of substitution, tiny Euler method, where you are going to substitute. As for me, I have to destroy whether this part or this part. Then I find whether a or b. Let me just start by finding the value of a, eliminating b. So for me to eliminate b, I have to check the expression which is the coefficient of b, which is x minus 4. For me to get 0 here, I have to say when x is equal to 4, that's for me to get 0 here. If I say x is equal to 4, this one becomes 0. So 4 plus 24, I get 28. Is equals to 4 here becomes 7. A. Finding the value of a, divide by 7, divide by 7. A is equals to 7 into 28, I still get 4, which is 14, 21, 28, I get 4 here. So a is equals to 4. Finding a, from there I have to find the value of b. For me to find the value of b, I have to say eliminating a now. So when x equals, for me to eliminate a now, I have to check the coefficient of the coefficient of a, x plus 3. For me to get 0 here, I have to put minus 3. Minus 3 plus 3, I get 0. So when x is equals to minus 3, so now here I have, for x, I have minus 3. So minus 3 plus 24, I get 21. Is equals to, then from there, there is a minus 3 plus 3 gets 0. This one becomes eliminated. Then from there, for b, I have minus 3, minus 4, I get minus 7, minus 7b. So for me to find the value of b here, I have to divide by 7 by negative 7. The coefficient of b is, so b equals a negative 3. Just remember our aim for doing this is to find the value of a and value of b, they substitute. So let me just say x plus 24 over x minus 4, x plus 3 is equal to, the value of a is 4, so I have to put 4 there, right there, over x minus 4. Then the value of b is negative. This negative, but this negative will affect this positive to come up with a negative 3 over x plus 3. This become the final solution on what we are supposed to do whenever we're dealing with partial fractions. So those who are new to this platform, please don't forget to subscribe on my YouTube channel. Also, don't forget to follow my TikTok page and also my Facebook page, so that you always enjoy more videos throughout this platform. So whenever you are given questions based on partial fractions, think about 4 ways of dealing with the partial fractions. The first one I said is linear factor. Then the second one is linear repeated factor. Then the third one is quadratic factor. Then the fourth one is improper factor. So basically, this is what you have to know whenever dealing with partial fractions. So thank you so much. Just enjoy this lesson.